Hey guys, this is Mr. Yo, and today what we're going to talk about is exothermic versus endothermic reaction. During this process, if you guys have any questions or if you guys want to solve any or go back to any notes or solve some questions, make sure to pause the video and do as accordingly. So, without any delays, let's move on. So the couple things I want to talk about is the potential energy diagram and the exo and endothermic reactions. That there's going to be a lot of graphing analyzation and a simple math calculation such as subtraction. So here we go. Potential energy diagram. Potential energy diagram basically means stored energy, or it's stored in bonds. There is potential energy for reactants and products, and the difference in potential energy is triangle H, or sometimes we call it delta H, or change of heat. That's another word for triangle H. If it's a positive number, it's going to count as endothermic reaction, while a negative number gives you an exothermic reaction. Now, all of these things will make sense as we go along and analyze our potential energy diagram. So here we go. Before we move on to the actual each details, what we need to make sure is the x and our y-axis. Our x-axis is the reaction pathway, how it's happening as we go along the reaction, while the y-axis determines the amount of energy being used. So, the first part about this graph is that there is called the starting point or the reactant. You guys probably heard about reactant from our chemical reaction or chemical equations. Now, reactants are the ones that are starting up our reaction. Following with the starting point, there is always an endpoint called the product. Now, in order for us to start up from the reactant or starting point to the product, we need some energy, and that energy is called the activation energy. It's the energy needed to start the reaction. Sometimes we have the symbol EA. E stands for energy, while A stands for activation. So that's another way to explain what EA stands for. Okay? Next, we have the activated complex, which also we call it the peak. It is the maximum amount of energy that we need to start up the reaction. Okay? Next, we have the final part, which is called the heat up reaction. Heat up reaction, which is also called change of heat, or delta H, is a simple calculation called the product minus reactant. Product minus reactant. Okay, the beginning minus the end. Or, I mean, the ending minus the starting point. All right? So now let's go in depth of what is the difference between endo and exothermic reaction. An endothermic reaction is when the activation energy is larger for the endothermic reaction. What it's basically saying is the distance between our complex or activated complex to the reactant is larger in this case. The reactant is lower than the product. As you can see, reactant is lower than the product. The potential energy must increase so energy is gained. Okay? So basically what that means is that endo means entering. Okay? Which also means absorbing energy. That's another way to remember endothermic reaction, which, as you can see, more energy enters the reaction. Now, you might see that the word heat. The heat is going to be on the left side because since you're absorbing energy, we start out with a heat inside. Okay, so that's why in this case, that should be an arrow sign. Reactant plus heat gives us product. And just like we mentioned on our first slide, our triangle H is greater than 0, which also means it's going to be positive. And you can probably figure that out, the reason why. The product is higher than our reactant. Okay? Next, we have exothermic reaction. As the activation energy is small for exothermic reaction, as you can see right here, it looks pretty small compared to our endothermic reaction. Now, the reactant is higher than the product. The reactant is higher than the product. And the potential energy must decrease so the energy is released. So if we think about a line, we can see that there's a downslope going on here, which means it will decrease. More energy exits the reaction. The reason why is the word exo means exiting. Okay? Another word for that means release energy. Okay? So endothermic was absorbing. The opposite of absorbing is releasing. And that is why exothermic reaction is releasing energy. So the reactant will create a product and heat on the product side since we're releasing heat. And since triangle H is less than 0, it means it will become negative. Not positive, but negative. Okay? So now that we vaguely understand what exo and endothermic reaction is, this is something I mentioned previously on. So you guys should be able to understand this. Now, if you guys remember the matters, state of matters, which is solid, liquid, gas, if we absorb heat, we will melt the solid into a liquid and liquid into gas. But if we're releasing heat, that means it's getting colder. So it will change from gas to liquid and liquid to solid. So I'll say colder here and hotter for endothermic. Okay? So now let's solve some problems and understand how to do it. If we look at reactant, how do we find a reactant? Well, just by looking at the graph and the y-axis, we can see that the reactant side or reactant is from here. Okay? And if we look at the graph, what is the number that we see? Obviously, 100. So our answer is 100 kilojoules. Now, what happened if we find the product then? Well, the product is over here. If we go that gives us 200. So that's 200 kilojoules. Now, how about energy of activated complex? Well, remember, activated complex is the peak. So that's going to be located right here. So if we were to look at it, that's around, let's say, 325, since it's in the middle. It can be, if you want it to be a different number, that's fine. Somewhere around that number would be perfect. So the answer for the peak, so activated complex is the peak, is going to be 325 kilojoules. Now, how do we find the activation energy? Well, activation energy is the difference between our peak minus the reactant. As you can see, the peak is going to be 325, since that's what we found, minus our reactant, which is 100, and that will give you 225 kilojoules. So visually, it's from the peak to the reactant, just like that. Okay? And last but not least, our delta H, or triangle H, is the amount of heat. So in an endothermic reaction, or in this case, we know it's going to be positive. So our product minus reactant is our equation. Our product in this case is 200, and our reactant is 100. So a simple calculation will give you 100 kilojoules. And that's how we figure out each part of the section. If this is too complicated for you, well, I would say rewatch the video and try to solve some questions that I've given you guys in your homework assignments. Okay? And that's pretty much it. So, well, actually, before we finalize this, there is one more term that I forgot to mention. It's called catalyst. You probably have seen catalyst in middle school. Catalyst is a way to speed up reaction. That is probably the definition you have heard of. But in this potential energy diagram, it means lowering. Lower the activation energy. That is the whole purpose in our catalyst for the potential energy diagram. And since it speeds up the reaction, it lowers our peak, or lowers our activation energy, or starting up energy, which means we will use less amount of energy. So if you were to draw this, the line must be above the product and the reactant, not below it. That is definitely an incorrect way. Always above the product and above the reactant. Okay, so don't make any mistakes when you guys are solving this kind of questions. And that is all. So finally, we are done. So if you guys need any help, don't hesitate to ask. Just call me through, or message me through email or on Schoology, or come during after school line time or whenever to ask for help. So there you go. That is all. And good luck with your study. I'll see you guys later.